Hello guys, welcome to Ramta Solutions and welcome to your lesson on differential calculus. Today we are looking at first principles. So at the end of this video you will have known, in fact it's something that you know because you did it in grade 10, average gradient, you know how to calculate it, and this is gradient between 2 points. And now, because you're in grade 12, you will be calculating gradient at a single point. And then we will then be giving you examples using first principle. Okay, so this is all that we will be doing in this video. So without any waste of time, let's begin. So you do remember average gradient, right? You do remember average gradient from grade 10. Right, so the average gradient between 2 points, right? Let me maybe draw a sketch. Let me draw a sketch. So this one here, let's call it a function f of x, and I will say, and then draw a line, a straight line here. No, it's ugly. Let me draw it here. I'll change the color. Let me change the color. Let me draw a straight line here, and then I will term this point here point A, while I call this one here point B. The x value at point A, I will call it x, while the x value at point B, I will call it x plus h. This meaning that the distance here is h, right? So the y value here will be f of x, while the y value here will be f of x plus h, right? Will be f of x plus h, okay? So this curve here is f of x. So what you were doing when you wanted to calculate gradient between 2 points, you said gradient between 2 points was m sub ab is equal to, I think you said f of let me say f at x of a, okay, b, not a, okay, b minus f at x sub a all over x sub b minus x sub a. And this was, what is f of x at b? It was x plus h, so this is basically f of x plus h minus f of x at a, it was f of x. So we said it is f of x, while x at b, we called it x plus h. As you can see, it is x plus h, and then x at a, we simply called it x. This therefore says you have f of x plus h minus f of x all over h, right? So this is gradient between 2 points, right? This is gradient between 2 points, right? This is gradient between 2 points, right? This is your gradient between 2 points. You use this gradient also in your analytical geometry, right? This is how you find gradient between 2 points, right? All right. Now, let's say you have a graph. I will give an example. Let's say you have a graph f of x equals f of x equals x minus 2 minus 3, okay? Yeah, minus 3. I think it's fine when I say minus 3. Yeah. So this graph will, and then the question says to you, find average gradient. Find average gradient. Okay. Find average gradient between x equals 1 and x equals 7, right? X equals 1 and x equals 7. So remember this formula here. It's the simple thing that you did in grade 10 and 11. However, as you can see, h is basically final x value minus initial x value. Okay, so we will say to find our answer, we will say I don't have to draw this graph, okay, or this function. I can simply say h is basically 7, since it's the biggest, 7 minus 1, which is 6. All right, even if you don't find h, you calculate it the way that you've always been calculating it, it's still okay. And then you say, what is f of 7? F of 7 is 7 minus 2 all square minus 3. This will give you 7 minus 5 is 25. Sorry, it's 5. 5 squared is 25. Minus 5, it's minus 2. Sorry. Yeah, it's minus 3. Yes. 25 minus 3 is 22. Then you look for f of x. F of what? 1. F of 1. F of 1 is 1 minus 2 all square minus 3. What is it? 1 minus 2, it's minus 1. Minus 1 all square, it's 1. 1 minus 2, it's 1 minus 3, rather, it's minus 2. Right? It's minus 2. So, gradient between these 2 points would be f of 7 minus f of 1 all over 7 minus 1. As you can see, the 6. Can you see it? Now, what is the gradient between these 2 points? It is 22 minus 2 all over, what is this? 7 minus 1. I can leave it like that. Now, simply, our answer is 24 over 6, which is 4. This is gradient between these 2 points. Okay? This is gradient between these 2 points. Right. So this is gradient between these 2 points. So this is the easiest thing that you are doing in grade 10 and 11. Now, let's get to what you should be doing in grade 12, or what you will be doing in grade 12. So remember, we said in grade 10 and 11, you were able to find gradient between 2 points. Now we want to find gradient at a point. Okay, now we want to find gradient at a point. Okay, now we will say gradient at a point. Okay, so I want you to consider a function here. I want to draw it as big as possible. I want you to consider this function here and consider a point A here and a point B here. Again, I'm going to take that white line. Okay, I'm going to take that white line. So now let's say, okay, since I put it here, okay, let me put my point A here. So here is where my point A is, right? It's yellow. So this is where my point A is. So this is where my point A is, right? So I want you to imagine it's easier for us to find gradient between 2 points, right? But then we now want to find gradient, let's say at this point. I'm going to show you first and first. I want you to imagine this. At this point, I'm going to call this point here. Okay, let me change the colors. I'm going to call this point here. I'm going to call it X. While I call this one here, I'm going to call it X plus H. And as usual, this means the length here is H, right? It means the length here is H, right? It means the length here is H, right? While this one here is f of x, right? This curve is called f of x. So the length here is H. That is the distance, horizontal distance between A and B. It's H. Alright? So now if I were to draw I'm gonna try now. Let me use a different color. I'm gonna try to, I want to move this line where it only touches the curve only once. Let me show you what I mean. Okay, let me move it. Okay, no, it's ugly. So I'm gonna draw it like this. I want it to touch, as you can see, it's moving away from B, right? It's moving away from B. As you can see, it's moving away from B, right? Okay, maybe let me move it a bit up. Now, oh boy. Okay, it's moving away from B. And then I'm gonna try another one. Again, as you can see, it's now touching the graph twice. And then I'm gonna try one that will be touching the graph only once, right? The next one that I want to draw has to touch the graph only once. Maybe my curve is not neatly drawn, it's not curving nicely. So let me make it curve like this. Maybe let me make it curve like this. Yeah, maybe let me make it curve like this. So I'm gonna make one. Now I'm drawing one. Yeah, let me draw one here. As you can see. Nice. Okay. So now when you look at these, you can see that as we move this point away from this line away from B, it approaches A. Can you see that when it approaches A? Now check the distance. We have moved B from here to here. H is decreasing. We move it from here to here. It's still decreasing. We move it from here to here. Now at this point, H is what? 0. Right? At this point, H is 0. Now let me tell you, when we say H is 0, it means we are limiting it. So you remember your gradient, right? You remember your gradient, right? Was your gradient was f of x plus h minus f of x all over h, right? This was between 2 points, all right? This was between 2 points. Now, when h approaches 0, this is what I mean. When h approaches 0, remember h was a big number here, and then it's low, it reduces until it gets to 0. When h approaches 0, we then say, oh, okay, so now gradient at a point, okay? Now we say gradient at a point is basically this gradient between 2 points, but it has a limit. What is that limit? This is when h approaches 0. This arrow here means h approaches 0. It's still the same gradient that you had between 2 points, but this one here, it is the h is approaching 0, i.e. the horizontal distance between the 2 points is approaching 0, right? Now, instead of writing it as gradient at a point, we call it f prime x, okay? So we say f prime x is equal to the limit of f of x plus h minus f of x all over h as h tends to 0, okay? As h tends to 0. This formula is the most important formula, okay? This is the most important formula that you're going to use here in grade 12, okay? It's called differentiation by first principle, okay? When we say differentiation by first principle, it's because we are using this formula, okay? We are using this formula. All right, guys. So we can now find the gradient. Remember, this f prime x is a gradient at a point, okay? So I will also give you an example where you calculate this gradient at a point. So without any waste of time, let's get to our examples where we calculate gradient at a point. They might be variables, and they might be functions, or they can just be simply getting a value. But let's just do examples. Now, examples. 1. Use first principles. Use first principle to find gradient. All right. 1.1 to find gradient of 1.1 f of x equals 2x. 1.2 f of x equals 1 minus 3x squared. 1.3 f of x equals 1 over x. 1.4 f of x equals 4. Number 2, find the gradient. Find the gradient at x equals 3. So for the second question, you are basically finding the value of the gradient. Okay, you are basically finding the value of the gradient at this particular point. So basically we say we are finding the gradient here. All right, so let's get into it. Our solutions. Number 1, you will remember we are using f prime x, this is first principle, equals the limit as h tends to 0, all right, of what? Of f of x plus h minus f of x all over h. Okay, now number 1, they said we're looking at f of x equals 2x, I believe. F of x equals 2x. Okay, it's this part here, we are sorted. Now we need f of x plus h. What does it mean? It means where there's x, we put x plus h. So this is 2 into x plus h, which is 2x plus 2h. Now we can substitute into this expression, which will say f prime x equals the limit as h tends to 0 of what? Of f of x plus h minus f of x on over h. So in your final examination, when you write this, you get a mark for writing this. Okay, now let's continue. We will say f prime x is equal to the limit as h tends to 0. What was f of x plus h? It was 2x plus 2h. 2x plus 2h. Minus, what was f of x? It was 2x. It was 2x all over h. Now, what do? We then say simplify the numerator. It is still the limit as h tends to 0 of 2x minus 2x. They cancel, so we're left with 2h over h. Again, as you can see, the h's are cancelling, right? So we are left with the limit of what? As h tends to 0 of 2. Now, we can drop this limit part. What it means is that when we drop it, wherever there's an h, we must put 0. But in this case, there is no h. So since there is no h, we can therefore say our derivative is 2. Our first prime, meaning our gradient, is 2. And this is how we find, we differentiate using first principles. Okay? This is how we find the gradient using first principles. Now let's get to number 2. Number 2 was f of x equals 1 minus 3x squared. Now f of x plus h will be 1 minus 3 into x plus h squared. This would be 1 minus 3 into x squared plus 2xh plus h squared. Okay, maybe let me go down. This will then be, or I should have written it there. Right, this is 1 minus 3 into, when you simplify this, it will be x squared plus 2xh plus h squared. Right, so this is using your FOIL method, right? Because you say this is x plus h times x plus h, which is x squared plus xh plus xh plus h squared. It then gives you this. Okay? All right. Now, we then say 1 minus 3x squared minus 6xh. I forgot the h. 6xh minus 3h squared. Okay? So we have our f of x, we have our f of x plus h. Now, we say f of x equals the limit as h tends to 0 of what? Of f of x plus h minus f of x over h. Again, the limit as h tends to 0 of, what is f of x plus h? We found it to be 1 minus 3x squared minus 6xh minus 3h squared minus, what is f of x? It is 1 minus 3x squared all over h. Now, as you can see, I know there are those who prefer to cancel immediately, but let me not do that. I will take this step by step, okay? Okay, so I will say we have f prime x equals 1 minus, okay, 1 minus 3x squared minus 6xh minus 3h squared minus 1 plus 3x squared all over h. I see what I did. I forgot something. Let me force it. The limit as h tends to 0, f prime x equals, right? Okay, so this is it, right? 1 times positive 1 is negative 1, and then, sorry, negative 1 times positive 1 is negative 1. Negative 1 times negative 3x squared would be positive 3x squared. Okay. Now, further, you don't have to be writing f prime x so many times. Even if you wrote it once, it's okay. So, we say this 1 minus 1 is out, negative 3x squared plus 3x squared they out, so we are left with minus 6xh minus 3h squared all over h. As you can see, you now have a common factor, right? You now have a common factor. What is your common factor? Maybe let me take it as h, not negative h per se. I just want to take it as h. It will be, I do understand, you can say negative 3h, it's okay, but there's no need. Why I'm saying that is because the h will cancel with the h in the denominator, so there's totally no need. So we'll say minus 6x minus 3h all over h. As you can see, the h's are now cancelling. Can you see that? The h's are now cancelling. So what are you left with? You are left with the limit as h tends to 0 of minus 6x minus 3h. Now, if you substitute h at this h 0 into h, you will not get an undefined response, right? Or an invalid response. So we can now drop the limit and substitute 0 into h. So when we drop it, we say we have f prime equals, I'm dropping it, minus 6x minus 3 into 0. Right? So the moment I start substituting h equals 0, I drop the limit. Okay? I drop the limit. Now, our answer, what is it? It is minus 6x. It is minus 6x. Right? All right. Now, let's get to the third one. Let's get to the third one. So the third one was f of x equals 1 over x. Therefore, f of x plus h would be 1 over x plus h. Now, as usual, f prime x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. And we have the limit as h tends to 0 of 1 over x plus h minus 1 over x all over h. This is interesting. So what we need to do now is to basically solve this. And to simplify this rather, we need to remember our knowledge on fractions is very key. So this will be x, I will show you x minus, it is a limit, it's x minus x plus h all over x plus h times x, and this over h. Okay? If you like, you can call this like this. You can say basically this is x minus into x plus h all over x plus h x h. Okay? You can say it like this if you like. All right? Let's confirm it. Yes, this will be, it's okay, it's okay. All right. So it's like this, okay, if you like. Now, let's simplify this. We have a limit as h tends to 0 of x minus x, okay, minus h over what? Over into x plus h and then x h. As you can see, the h's are cancelling, right? The h's are cancelling, right? So what are we left with? Now we will be left with minus 1 over, I will show you just now. We are left with the limit as h tends to 0 of minus 1 over into x plus h times x. Right? So if you like, this one, you can also, I don't know, okay. You know what, let me just do this. I should have done this maybe. You can also call it x squared plus xh, right? If you like. But what I can advise is that you don't have to go this route. You can just say, because you want to save time, you can just say, you know what? You can see now that if you place in place of, if you put in place of h, you put 0, you will not get a denominator of 0, right? So it will not be invalid. So you can drop the limit and say, what you have now is minus 1 over x plus 0 times x, isn't it? What is it? You have minus 1 over x plus 0 is x times x, it is x squared. And this will be your answer. Okay? This will be your answer. And this is you now saying, oh, I am able to find the gradient using such. Imagine dealing with such. So look at it. You're like, oh, wow, f of x equals 1 over x. Look at its first prime x, meaning its gradient. It is minus 1 over x squared. Okay? By the way, we call this f prime a derivative, first derivative to be precise. Okay? Now, number 4 was f of x equals 4. Now, what is f of x plus h? There's no x that you can substitute f of x plus h into. So f of x plus h will still be 4. Okay? Now let's go. F prime x equals the limit as h tends to 0 of f of x plus h minus f of x all over h equals the limit as h tends to 0. What is f of x plus h? You said it was 4. What is f of x? You also said it was 4 over h, right? Now we have the limit as h tends to 0 of what? 0 over h. You know that 0 divided by any number is 0, right? Right. So I repeat, 0 divided by any number is 0. So we have the limit as h tends to 0 of 0, right? Of 0. Therefore, this will also be 0, right? This will also be 0. And this is it, guys. So this is our first prime of x, or our gradient, and our gradient is this. Now, we are going to find gradient at a point. Remember, the second question was saying we must find gradient at a point, right? We must find gradient at a point x equals 3. Let's see. For the first one, what this means is that where there's x, we put 3. Let's see. So, let me call it 2.1 basically. Yeah, let me call it 2.1. Did I call it 2.1 or what did I do? Okay, 2, it's fine. I'm going to call it 2.1. That's fine. So 2.1, this is where f of x was 2x. We found that f prime x was 2. Let me confirm. Yes, it was 2. So now, here's the thing. When we say gradient at a point, we mean where there's x, we put a point. So what is that point? 3. I mean, is there a 3 here? I mean, is there an x that we can substitute this 3 into? No. So gradient at x equals 3, it's still 2. We are done. 2.2, it was saying f of x equals 1 minus 3x squared. Our gradient was, by first principles, it was minus 6x. I will confirm. It was minus 6x. Yes, it was minus 6x. So gradient at x equals 3, what is it? In other words, f prime of 3, what is it? It is minus 6 into 3. And this is minus 18. 3 marks, eh? So it is minus 18. This is gradient at x equals 3. Now let's head to number 3. Number 3, it was f of x equals 1 over x. Our gradient, f prime x rather, yes, it's still a gradient. F prime x was minus 1 over x squared. I will confirm it. Yes, minus 1 over x squared. So now we want gradient at a point. What point are we talking about? X equals 3. So where does x, we put 3, remember? So this is 3 squared. So what is gradient at this point? It is negative 1 over 9. Easier. Now 2.4, that was f of x equals 4. The gradient was 0. Now please find gradient at x equals 3 for me. I'm going to give you a minute. Your time starts now. Oh, somehow someone feels that a minute is too long. So the question here is, we said f prime x is 0, and now we're saying f prime x equals 3. Where do you have x value here? You don't have an x value. So at this point, your gradient is at x equals 3. It's still 0. And this is it, guys. So stay tuned for your next lesson. In your next lesson, you will basically be finding this f prime x without using first principles. Okay? You will be finding this f primes without using first principles. Remember, when you see f prime x, we call it a derivative, right? It's a gradient, right? It's a gradient at a point as well. It's a gradient at a point, but you can call it a derivative as well. First derivative. To be precise, it's first derivative, okay? Which means a gradient at a point. Okay, guys? So this is it. See you next time, and bye-bye.